Welcome back to Ox Tools. I'm Tom. So today what we're working on is we're working on the Kearney and Trecker jig bore, and I've got the pulleys mounted, and what do I want to say? The motor pulley is this adjustable space V-belt pulley, and it's got a very long hub to it that's longer than the motor shaft. So we're going to make a little. It has a tapered coupling on one side, but the tapered coupling doesn't extend the full length of the hub. So I want to add something to the other side that helps support the pulley. This particular motor that I have came off of a big pump, so it has a threaded shaft on the end. So the bushing we're going to create is going to slide over the shaft, and it'll thread on, which will lock it in place. So I did a little SolidWorks model of it, and I'll show you that in a sec. I'll show you the drawing anyway that I produced from it. And I've got some steel that has a little side story to it. And so let's go around the lathe and let's spin out a bushing, and we'll mount it up on the machine. Okay, so here's this is a little motor bushing we're going to make, and I'm tipping it at a weird angle because you can't see it like that, right? So this is just going to bush the end of that motor to the pulley on the jig bore. So what I'm going to make it out of is I have some 1144 Stressproof here that I rescued out of the trash bin shop down the street. They had some old shafts that they threw away that were 1.5 inch ground and polished shafting. So they look pretty good. Actually, there were some worn spots, but most of it was kind of untouched. So I brought it over and I did some test cuts on it. I'm pretty sure it's stress proof, but it'll be fine for this job. And so let's see here. What's first here? Take a look at our drawing here. We got a couple diameters, a bore, and some threads, and then we got a bushing. So let's go to town on this thing. And for those of you that haven't tried Stressproof, it's kind of the cream cheese of steels. It's really strong and machines like butter almost, and screw machine guys like it. It's just some nice material here. Alright, so I got to calibrate my tool a little bit. Alright, we'll take a cut off of this. Let's get some feed going here. So I know where I am here. Alright. 1 inch 407. 07. Enter. Okay, so I've just calibrated my tool tip there. So what's my major diameter? 1 3/8. Alright, so I'll get close and then I'll do some more roughing. So it's hanging out a little ways, but it's pretty large diameter, so I'm not going to sweat it here. I'm going to turn it back a little ways. Alright, and then my first step is about 875 in, so I'll get close to that, and I'll put a little witness mark there, and then I'll dig this out. You can see how the chips break really nicely.
It's just, like I said, it's like cream cheese. Alright, so this little over 1 inch. And now I'll start poking a hole through it. So my preference on this kind of stuff is you know, if it's a short stubby part like this, what I like to do is just kind of work all the features and get them kind of close, and then go back and do the fine finishing work towards the you know, kind of as the last step. So rough, semi-finish, and then finish. So let me get some drills and get set up with a boring bar. Okay. Going to rough it with the tap drill size for the thread, which is 7/16 20. Kind of an odd size, but that's what's in the end of the motor. The big drill here, then low range, and this is undersized here. I just put a mark on it to get me close, and then I'm going to go in with a boring bar because I want that bore concentric with that diameter. You see how the chips break really nice with this stuff? It's just a pleasure to work with. Okay. Get that out of there. Alright, so let's probably get those diameters down and then do the bore, and we're off and running. Alright, let's do our, this is cooled off enough. We'll do our finished diameters now. I've slowed the feed rate down. measurement. Oop. 99985. I think that'll work. This diameter is not so important. It's just a, oops. It's just a, you know, a flange diameter here. It doesn't fit anything. All right, 1 3/8. Okay, so I think we're ready for some boring action. Boring action? All right, so let's come up. And this is a little insert boring bar. Let's see, can you see that? Yeah, you can see it. All right, so we're going to come up and just calibrate our tool on this face here. And I'm just using a piece of 1 mil shim stock, okay? Oop. Yeah, and I say oops once in a while. You know what? So what? Okay. All right, so what I want to do here is so I got a rough drilled bore here. What I want to do is just take a little skim cut that cleans that up and then get a good measurement so I can calibrate my tool. Let's do that. I'm going to come up. I'm just going to kiss that a little bit. Like that. Come up. Give it a couple thousandths. Okay, and then I'm going to bore in a little ways. Enough to straighten up that bore and everything. Okay, and you can see that the diameter's it's smooth on the entrance here, and now I can get a good measurement. So let me, I don't have any ID measuring stuff, so let me go grab something. So this will allow me to calibrate my tool. I think I want that one so I can see it. Alright, let's see what we got. $617. Okay. Oops. Oh, you dope. 0.617. Enter. Accidentally punched the Z there, so let's re-establish that. I accidentally hit zeroed the Z away from the part there. Oh, come on. What is your deal? Okay, there we go. Thank you. Okay, so I think we're ready here. Let's stuff a little oil in there. Let's go to, that was 617, so let's go 620, and we'll go to depth. See how that, okay, it's cutting. I didn't think it was cutting, so I wanted to look. Chips coming off. 5, 6, 7. I'm hand feeding the last bit since I'm in a drill hole. So, you know, I'm going to get a 625 pin, I think, and that'll be our gauge. So let me go grab a pin. this should be our finished pass, I hope. And then I push it I back it that way so that I don't drag the tool tip against against that nice board that I just did. So that's right. I want to start, but not quite. It's the air keeping it from going in. And this is a minus pin too, so I think we want to take a little spring pass on that, so that we're good here. So let's do that. Reapproach. 6, 2, 5. Okay. There's some fuzz coming off. So, you know, all tools push a little bit, so you can, if you go back to your same setting, sometimes you can get a little scrape off of it. Yeah, see, we got a little bit, but it's just not much. All right, let's see what we got. That should just fly in there now. Okay, piston fit now. Okay, so a couple little, let's see. My diameter was good there, right? I forgot. I forgot. So this is, you know, this is what happens. You're filming or something, right? And you're like, hey, did I do that diameter? And then you part it off, and then you realize that you didn't. Okay, now I'm good. So I can't remember everything, guys. Okay, so I'm gonna put a little chamfer on that, little chamfer on that, little chamfer on that. I'm gonna lop this off, and then we're gonna turn it around. We'll run a tap through it. Okay. All right. So. Chamfer action here. So I put it in this way. That way I can catch all those edges without a tool change. I can do the ID here. Just break that, come out, break that edge. Then I can come up and do this one, like so. And stick Mr. Porting tool in here. And my overall length is 1 1/4, but I'm going to go a little strong on that so I can face it off. So this might be a little fast, but let's see how it goes. Seems to be okay. Fine. So there's our bit there, and so now what I want to do is I want to just face it off the length. So I'm just going to measure it, the overall length. Okay, so 1 inch 281. Okay, 1 inch 282. Okay, so what we're going to do, we're just going to plop it in there like so, up against that, and then crank it in there a little bit. And then what I'll do is I'm going to come up and touch off here. Okay, actually I'll just do it without the spindle on. So I'm just going to come up and touch off, okay, like so. And you know what, I'm gonna show it on the DRO here. So let me switch to the DRO. Okay, so now what I'm going to do is I'm going to negative 1.2, oops, come on. Negative 1.2 0.2. Oh, it won't let, you know what? I just noticed that. It won't let me enter the negative sign first. 282, negative, enter. Okay, so now when I move my Z, okay, now I'm moving away now, right? So what I can do is I can just work, I'm going to move that out. I can work right to my number. So I'm taking a direct measurement here now, as opposed to just reading a difference, a delta between my measured value and where I am. So I can actually put the actual dimensions in here, and then so it makes it so bozos like me don't make mistakes. Okay, so let's go back and we'll face this off and then tap a hole. Okay, so kind of ready to go here. I'm going to go down to my number. I'm just going to go right to size. I'm not going to mess around, taking multiple cuts or anything. Okay. Give it a little wisp of oil. Break that edge nicely. Alright, and then I'm going to catch this edge while I'm at it, because that's where our tap's going to go through. Let's give it a little more. Okay. Alright, put that in low range. Let's see. Oh yeah, that'll be fine. Let's just go for it. Let's just go for it. A little Earl. Through. All right, now we'll go get out of there in reverse. Okay. So I think that's it for lathe work on this part. Let's actually, just for fun, because I know you guys are curious, let's just take that out of there. Wipe it off. Let's see how we did on the length with the quick calibration method. Okay. 40-some, couple thousandths. Depends where you measure it. Let's go across the center. 48, okay, 2,000ths, that's pretty good. Now, you know, if you needed it closer than that, then you would, you'd measure to, and face and measure. So a lot of times when you part off at a, you know, there's a little belly to the part. So if you needed that to be exact, you'd measure it and then cut and then measure again. Okay, so let's go, I think we're ready for the mill now. All right, so let's get this going here. So I'm going to put it in a V block here. I'll set it down on the top of the V block like that. So V blocks for round stuff in the mill is good because you have 3-point contact. So let's just cinch that up, okay? And we'll center this thing up. Alright, and what I'm going to do initially here is, so this just gives me some idea of how far off I am, which is a mile here. Alright, so let's get a little closer. Now I can kind of see what I'm doing there, right? Alright, pretty close. Alright, so now I think I am ready for contact. And of course I'm going the wrong way. So this one's got a little fine adjust on it too, which is kind of cool. And So I can get it close and then I can bring it into contact like that. And honestly, I don't really care if you can see the see the indicator or not, guys. You know, I don't think it's very meaningful to this discussion. Okay. All right. So we're centered up. Now we're gonna cut. A couple of flats on here so we can get a wrench on this thing. Okay. And the width is 1.25 inches. So let me find a tool and then we'll cut some flats. Okay. So I got a tool in here, 3/8 carbide end mill. I come over and zero on that surface there with the quill readout, beep. Okay, and then our depth, we're not going to cut all the way through that flange. We're just going to go down about 300 thousandths. But we got to come out a little ways. So let's. So the width of our flat is 1.25. Half of that is 5/8, and half of the cutter is 3/16. So that's 13/16. So that would be our number off of center line. Okay, the theoretical number. This is a regrind end mill, so it's going to be. It'll have to come in a little farther than that to get to our 1 1/4. But what we'll do is we'll measure it, and then we'll see what the offset is. So let's go down. Let's go maybe 100 thousandths. And let's get up around, I don't know, 1200 RPM, something like that. And let's whittle away at that. Suppose the other way. So the other way I could do that is I could touch off of the outside, but knowing where you're touching, you really want to be on the quadrant, right? So for these kinds of things, I prefer to work from the center out. But you could touch off here and then move in a particular amount, then that cancels the cutter diameter, if that makes sense. So I think we're just going to go into our theoretical number. Okay. Okay, and then I'm going to come around this side and do the same thing. Like so. And then I'm going to take a measurement and just kind of see where this is. Okay. Little calipers are getting magnetized here or something. Oh, it's actually pretty close. Huh. Okay. Oh no, 63. Oh, you know what? This thing's got a little corner radius on it. That's why. That's what I was measuring. Chips off of there. Kind of side saddle on this thing here. Alright. Wow, they didn't take much off of this cutter, did they, huh? To sharpen it up. Alright. Well, it's pretty close. So let's go down to our depth. I'm just going to go down to just shy of our 300. Let's go 290. Alright. And then we'll whittle away at that. so I'm going to go down to depth now. Our 300 depth, and I'm going to take the last 2 thousandths or so off to the side, or 8/11, okay. Come over here. Do the same thing. Alright, that should be it. Run my calipers on the, alright, 1 inch 248, okay. And so do a little deburring on that, and we'll go try it. So I decided to go ahead and, since I put a chamfer on there on the lathe, so I'm going to go ahead and machine one in as well. And I think some of you guys have seen me do this before with a countersink. So basically I'm just going to match what's there visually. And a little bit more. Just for fun. A little bit more. Yeah, looks pretty good. Okay, and my number is 771 off of the center line. So I'll just come over here and do that same number. 771. Voila. Okay, chamfer. That sometimes beats filing that, you know. You got this nice machine one, and then, you know, what do you do, right? Okay, so there's a, so it's got an expanding coupling on the other side, but there's a bit of unsupported pulley. That's why I wanted this bushing that we just made here. So let's put that in there. And it looks like it's going in, and the little flats are so I can tighten it up. I don't have a wrench, but anyway, that's the general idea. And it supports that end of the pulley, you know, because there's some belt loads on that pulley that may want to pull it off axis there a little bit. So, and it just kind of cleans this up. So we'll make a cover for that that's got a little bump in it for this projection here, and that'll cover that end up. And then here you can also see the how this pulley adjusts widths. Here's the threads on the hub, and then this is threaded, so that one flange can move in and out to adjust the pulley pitch diameter. Okay? Anyway, motor bushing, done.